Okay, here it wants us to match the conservation of energy equations at the right with the following situations at the left. So this might look a little bit confusing, but let's go ahead and start analyzing, and hopefully it'll make a lot more sense. So A says an object is thrown into the air. Well, when an object is thrown into the air, it's moving, right? We have kinetic energy at the beginning, so either 1, 3, or 4. And then how high it goes? Well, at maximum height, your velocity is 0 meters per second, and it's not moving. And at maximum height, you have your maximum potential energy. So you have a situation where an object starts with kinetic and ends with potential. So that's going to be number 3. So we can write number 3 here. Alright, B, an object at rest is moved. So an object is at rest, there's no energy. So we should have a big fat 0 at first, but then it's moved, so there is work being applied to that object, and it ends up with kinetic energy because it starts moving. So these are the two zeros, work's being applied, and it has kinetic energy at the end. Number 6. Okay? A moving object slows down due to friction. So a moving object, we know we have kinetic energy, because kinetic energy is the energy of moving objects, and it slows down due to friction. So friction is doing negative work on the system, it's taking energy out of the system here, but it only slows down, it doesn't stop. So you still have a kinetic energy afterwards. So we have, let's look at number 1. We have a kinetic energy with negative work, and then we end up with kinetic energy afterwards. So that's actually the perfect description for C. So we'll put 1. Alright, an object is dropped. So at first, before it's dropped, it's going 0 meters per second. It's as high as it's going to go because it's going to fall after that. We've got all potential energy. How fast is it going? Part way down. Alright, well, halfway down, or even part of the way down, you have a kinetic energy because it's falling, but you also have a potential energy as long as it's above the ground. So we had potential, and then we ended up with potential and kinetic. So that is number 2. Okay, E. A spring is compressed. So first we had a situation where there was no energy, and then work was applied, and now we have potential elastic energy because the spring was compressed. So 7 is an accurate description. We had no energy, work was applied, and now we have potential elastic. Alright, F. A compressed spring, so we know it starts out compressed. We start out with potential elastic energy. Shoots an object into the air. So if it's into the air, we know it's moving, it's got kinetic, and it's in the air, so it has height, so it has potential energy. So here we have potential elastic, and we end up with kinetic and potential. So number 5 would be an accurate description for F. Alright, and then a moving object is stopped. So it was moving, kinetic energy, it stopped. So negative work, stopped it, and now there's 0 energy. Oh, here we go. We have kinetic energy, negative work was done on it, and now it's stopped. So G would be 4.